Good afternoon, this is Kevin with Power Products and Services demonstrating installing an analog PCU module onto an RCEL electric actuator. Here is the PCL unit itself. It comes with a mounting bracket here that you pull the, basically you have to pull everything off the shaft, slide this, mount the circuit board to the bracket slides onto the shaft and then attaches via a long Allen screw and some spacers there. So that mounts the actual PCU control board. Then the next thing you have to do is install the potentiometer underneath with a washer and then a small washer here. Then you install this shaft or this gear that's on the actuator shaft, and then this shaft is on the potentiometer, which when the shaft turns, that turns the potentiometer, creates ohms that are given to pins 4 and 5. So a couple tricks that I did was, first thing you do is in calibration mode, you pull this little jumper out of here, and then you set your 0, which is done by this potentiometer here. And what you do is you watch and turn that until the close limit switch gets triggered. So you use that as kind of a gauge of when to set your 4 milliamps. And then the next step is the span. Now the span is it's not a direct measurement of your 20 milliamps. It's basically a percentage off of the 4. So it's you really have to start with your 4 milliamps, get that set, and then set the 20 milliamps. And if you have to adjust your resistor or gears or any of that nature, you got to kind of start over and make sure you do your 0 and span calibrations first. And then another little trick I learned is I drew a line on the potentiometer, and then I measured the resistance across the black and white wires, and I determined that this line right here was about 442 ohms. If it was shown at exactly 9 o'clock. So what you can do is you can kind of use the potentiometer and measure the ohms to kind of figure out your midspan. So once I set the open and close on the actuator, that kind of knew where my start and stop was. So then I documented the ohms on my midpoint, which was 12 milliamps, was 500 ohms, and then at 4 milliamps it was 410 ohms, and then at 20 milliamps it was 650 ohms. So you should see an increase in ohms with an increase of milliamps, which is an increase to open. So open equals counterclockwise. Here's kind of my rule of thumb that I live my life by. Open is counterclockwise, 20 milliamps. Close is clockwise at 4 milliamps. Okay. And then, okay, so then once I tested that out, got it wired up, ran the calibration mode, then in normal operation mode, I did notice that it does kind of step between values. So right now I'm sitting at 12 milliamps. I'm going to set it to 20. I set my signal generator to 20 milliamps. And then you do see it kind of step along its way to get there. That is by design to help decrease wear and tear on the motor. So with analog controllers, it is normal for them to step along their way to and fro. And I believe that is about it. Thanks for watching.